are going to continue with the next lesson. Lesson 6 is going to take us just to the end of the embryonic phase. And so you'll notice when I'm telling you when things are happening, like is it week 1, week 2, week 3. And I said the other day there were 40 weeks, give or take, a few where a woman is pregnant. A lot of stuff is happening at the beginning, and that's when the bulk of the things that we discuss are occurring. So the end of the embryonic phase is only going to take us to the end of the 8th week of pregnancy, leaving us with 32 more weeks after that. So we're going to start with week 3. So remember, week 1, that was the week it took for the fertilized egg to move through the fallopian tube and get all the way to the uterus. Week 2 was where gastrulation was happening, where those 3 layers were forming, and now we had differentiated cells. Week 3 is where something called neurulation happens. This is the beginning of the formation of the nervous system itself. Now, much like with gastrulation, I put a picture here, not because you have to be able to recreate it or redraw it or anything like that, but I just wanted you to see what I'm talking about. So, during this process, we start off with the gastrula. So that's this little guy down here. We have 3 layers of cells, because that's what happened during gastrulation. Now, through quite a convoluted sequence of grooves forming and bending happening, at the end of this process, instead of just 3 layers of cells, we start to see some structures forming, especially at the top. This picture is focused on just what's happening at the top here. So there is a thick band of mesodermal cells. That's the middle layer. And it forms on the dorsal, so back part of the embryonic disc. It's called the dorsal cord or the nodal cord. That is going to become the beginning of the skeleton there, so bones. So we've got this chunk of mesodermal cells that's going to become bones. So in pink here, there's the nodal cord. It's this thick band. There are other cells that are part of the mesoderm. We're just focusing. See where the nodal cord is here? It's right in the middle. We're focusing just on that little bit of the mesoderm. So we've got this thick band of mesodermal cells. The ectoderm, which is the blue part here, it's above the nodal cord, is going to develop into the nervous system and the skin, but the nervous system. So this layer of ectoderm starts to fold in on itself. So you'll see there's 2 different colors there. The cells are not 2 different colors in real life. That's just how the picture is. But essentially, we take those outer 2 pieces of it and kind of pull them together at the top. And so if you watch this folding process happen, we kind of go clockwise around this picture. Instead of having 1 layer of ectoderm, this little fold that we've done gives us 2 layers. An outer layer that's going to form the epidermis, or the skin, and this inner layer that kind of looks like a tube now, that's the neural tube, and that's where the brain and spinal cord are going to begin to form. And then soon after, this little red bulge will start to form in our developing embryo. It's where the heart is. And on or about the 18th day, it starts doing stuff. Now, you can't hear it at this point because structures are not really formed to any degree, but now, what happens after that? Well, those first 3 weeks really saw a ton of stuff happening. We went from 2 haploid cells to diploid cell to implantation to differentiation. Now we've got different layers of cells. Now we've got a nervous system starting to form. Now we've got a heart starting to beat. Over the next 4 weeks, organ development starts to occur. None of the organs are going to be finished at this point, but this is when things get started. So this picture that I have here for you represents some of the Carnegie stages. if you've ever been in a doctor's office, especially one that specializes in delivering babies, or even ones that don't, it's a much larger picture, like there's more of them. So I'm just showing you a little excerpt of it here. You'll see my little legend here. That is a centimeter. So a centimeter here. Structures are not big at this point, and I really want to emphasize that. Nothing is big. Even when I take a look at 56 days, which is 8 full weeks, and it looks like a baby, right? You can see a head, you can see arms, you can see stuff there. Look at my scale. That's a centimeter. It's only a couple centimeters. Like, it's not big at that point. Now, here are some of the highlights. During the 4th week, so if I'm looking at the days here, this says 28 days. So at the end of 4 weeks, we would be at 28 days. We get lots of growth, lots of cells forming. Stuff doesn't really look like stuff yet. It looks like a clump of cells at this point. If you zoom in really close, you can kind of see some structure, but even in that little clip we watched, like, it did not look like a human shape yet at that point. It looked like a clump of cells. Some cells that are going to be the lungs and kidneys appear. Buds start to appear. Eyes and nose and head start to form. Week 5, so 5 weeks, would take us to about day 35. So that's between picture 15 and 16. The head starts to really enlarge at this point and become large compared to the rest of the body. The eyes start to look like eyes. They don't have all of the structures yet. Like, there's no eyelids. There's no iris. In the 6th week, so 6 weeks takes us to about 42 days. So right between pictures 17 and 18. Brain is developing, and the limbs are really starting to lengthen and bend. And if you notice here, like, you can start to see, oh yeah, that's where the legs are going to be. I can see them. Whereas up until this point, it really didn't look that distinct. There was a top and a bottom, but that was really it. This is where gonads, which are the reproductive structures, start to produce hormones. So, for example, estrogen or testosterone or things like that. Now, week 7 would take us to 49 days, so right between picture 20 and 21. And week 8 would take us to 56 days. Now, during those 2 weeks, most of the rest of the organs are forming. They're not finished, right? They're not done, they're not mature, but they're on the go. The nervous system is going to start coordinating things. There's a cartilaginous skeleton, so the bones have started forming, but they're not hard yet. They're still really pliable. Eyelids form there. Nostrils are there for the nose. They're still blocked, but they're there. Physical sex is not apparent at this point, although if someone really needed to know, there are other tests that we could perform to determine that. But here's what you need to know. At the end of the 8th week, the embryo is basically the size and mass of a paperclip. It is tiny. If you looked at a woman who was 8 weeks pregnant, it would be difficult for you to know that she was, because everything is so small still at this point. But 90% of the structures have begun developing. They are not finished, but they're on the go. Now, from this point on, we call it a fetus instead of an embryo. We're at the end of the embryonic phase. But remember, this is just the baby. This is the zygote that was made from the 1 sperm and 1 egg that went through segmentation, that implanted itself in the uterus, and now those cells have begun multiplying. Now, if you look on the whiteboard, Mrs. Paulgard has conveniently written exactly what I would want you guys to know here. See here? Zygote, it's in the fallopian tube. The blastocyst implants itself in the uterus. And then the embryo, we call it that, all the way up until the end of the embryonic phase, where we call it a fetus. She's even got up there stuff about the chorion and the placenta, which we'll talk about next. But 8 weeks is when most of the good stuff happens. And so consider this. After 8 weeks, The woman probably knows she's pregnant, but there's not a lot going on here, right? Like, it's not like it's out like this and there's a humongous human baby growing inside of you. For some women, their cycle is irregular, and 8 weeks might not be enough time for them to really realize, oh shoot, I've missed one of my cycles, because maybe they don't expect their cycle as often as other people do. But everything's on the go. Like, this is a little baby. It's got stuff. It's got a nervous system. It's got a heart. It's got a skeleton. It's got organs. It's super tiny, but it's there. Now, we're going to continue talking about what happens weeks 9 and on in a few slides, but we got to pause here and talk about these support structures that I keep alluding to. As our little embryo develops during the embryonic phase, these structures develop. These support structures are called extra-embryonic membranes. The word extra means beyond, like an extraterrestrial is from beyond the earth. But these extra-embryonic membranes are formed from the same cells as the embryo. Everything starts with that one zygote. So all of these structures form with the same set of DNA that our one original zygote had. None of these structures form unless there's a zygote that turns into a blastocyst that implants itself into the uterus. So I mentioned the amnion before. Here it is again. It's a transparent sac that envelops the embryo, fills with liquid, so kind of like a shock absorber to protect from mechanical, physical damage, but also to allow freedom of movement. Then there is a structure called the yolk sac. It is yellow here. It looks like a tiny bag hanging from the abdomen. It will contribute to the formation of the digestive system in terms of enzymes, eggs and sperm that are part of the reproductive system as well. But it does not have a nutritional function in humans the way it does in other organisms. And I'll explain that in a minute, because when we're done this slide, I'm going to show you what it would look like in other organisms. Now, eventually, this yolk sac, you can see here, it's forming a tube between the baby and the placenta. The allantois is the other structure. You should really say allantois because it's a French word, but I'll just say it that way. Allantois, that's how you'd say it. It's the base of the umbilical cord, and it will form the bladder. And if you look, the allantois and the yolk sac kind of go together to form the structure connecting the baby to the placenta. Then there is the chorion. It is the outer layer. So the blue layer is the amnion, the pink outer layer is the chorion. The chorion is what the trophoblast turned into. So remember when it was a blastocyst, there was a clump of cells and an outer layer. We called the outer layer the trophoblast. Now we're calling it the chorion. It encompasses all the others that we mentioned. So it goes around all of the other structures. It's the outermost one. It also forms the fetal part. So fetal is an adjective that refers to the fetus, so the baby's side of the placenta. And I'm going to show you the placenta on the next slide, but if you look down at the bottom here, you should see these little tree-like, finger-like projections sticking out. Those are the chorionic villi. They are extensions of the chorion, but they look like little trees or little finger-like projections. That's the baby's side of the placenta, the fetal side of the placenta. If you remember digestive system in Bio30E, you have these same types of structures in your digestive system in your small intestine. Okay, so you had villi and microvilli in your small intestine. Same kind of structures here. Now, does anyone want to ask anything about any of these structures? It is super probable that you would have to identify them on a diagram. Chorion on the outside, amnion right around the fetus, then allantois and yolk sac forming the umbilical cord. Now, if we consider the placenta, this picture over here has zoomed in on just the umbilical cord. That's the piece at the top. And just a little piece of the placenta so that you can get an idea of what it looks like. So what is the placenta? It is richly vascularized. That means lots and lots and lots of blood. It's an organ. It fixes the embryo to the uterine wall. Metabolic exchanges take place through it. It's only fully developed by the 10th week. And we mean the 10th week of pregnancy. So starting from day 1 for the baby. That means a woman doesn't have a placenta if she's not pregnant. Okay? It only develops if pregnancy is occurring. Part of it comes from the chorion, and the rest is made up of blood from the mother. It also means, since it's only developing when a woman is pregnant, she also doesn't need it anymore when she's not pregnant. And you'll see when we watch the birth videos that the last stage of delivery of a baby is actually the delivery of the placenta. The placenta has to come out just like the baby does. So here are some things that the placenta does. It has a nutritious function. Things that the baby needs, glucose, amino acids, fatty acids, minerals, vitamins, can be transported through the placenta. It can have an excretory function for things like urea or ammonia. It has a respiratory function, gas exchange between oxygen and carbon dioxide. There's an endocrine function. Hormones can make their way, HCG, estrogen, progesterone, other hormones that I didn't mention there, but they can. It can also have an immune function. The mother's antibodies could pass through the placenta to the baby. That could be good or bad, depending on when you heard about Bio30E. You may remember learning about how there's a scenario where mom might have antibodies against the baby's blood type, and mom attacks the baby's blood. Do you guys remember hearing about this? Mom has, say, O negative blood, and baby has, say, O positive blood. Is that a familiar thing to people? I see some people nodding their heads. Essentially, mom might have antibodies against the baby's blood type if they don't match up. So the immune thing could be good, could be bad too. There are some other things that can go through the placenta, bad stuff, that I'll talk about on another slide. The umbilical cord is the other part of this. The umbilical cord really is just the yolk sac and the allantois together. So by about the 8th week, the yolk sac has shrunk down, the amniotic sac has gotten bigger because the baby is getting bigger, and this is when the cord is starting to fully form. It's about 60 centimeters long and about 2 centimeters in width, give or take, when it's fully grown. It has 2 arteries and a vein. So if you take a look at the top there are your arteries and veins. You can see they're kind of twisted together, and this top little piece is the umbilical cord. Now, if you follow these blood vessels, focus on this middle part. See how the blood vessels from the baby come down and make sort of a tree-like, finger-like projection structure? That's the baby's side of the placenta. That's the chorion and the chorionic villi coming down. The darker red spots that are sort of thicker, that's mom's blood. That's mom's side of the placenta. Notice how the baby's blood, which are in these little blood vessels, and mom's blood in these kind of larger sections, there's no connection. They don't connect to each other. There is a space between them. The only thing that is supposed to happen is that material can diffuse into mom's blood from baby or vice versa, okay? So mom's blood and baby's blood are 2 completely separate sets of blood. Anyone want to ask anything about that? Okay. Now there are some technologies associated with these support structures. One of them is called chorionic villus sampling, or chorionic villi, if we're using the plural. It's a prenatal test where we can take a little sample of the chorionic villi. It's not without risk, but it's also something that is that can be done safely. It's not a routine test. You wouldn't get this unless the doctor asked you to or you requested it, so this isn't something that is routinely done. But we can take a little bit of the chorionic villi. Why would we even want to do that? Well, remember, all those support structures came from the same original zygote that the baby is coming from, same genetic makeup. So we can test for chromosomal conditions like Down syndrome. We could test for other genetic conditions like cystic fibrosis. You could also do this for paternity testing, but this is a pretty advanced thing to do just for a paternity test. Another technology is called amniocentesis. It's a procedure where you take a bit of amniotic fluid, so a bit of the fluid out of that sac, and then we take it for testing or treatment. Genetic testing, often fetal lung testing, because the baby's floating around in there, and it can help us determine kind of gas exchanges happening. Fetal infection. Sometimes the amniotic fluid will develop, or viruses could enter there, bacteria could enter there. Paternity testing is another one. The last one is probably the most common technology. Most people, especially these days, who live here and have access to healthcare would have an ultrasound at some point during their pregnancy. Maybe when I was a baby, it wasn't a thing. Like, I remember my mom telling me she only ever had an ultrasound when they thought she might have miscarried a baby, but it wasn't standard. But I had 3 different ultrasounds with my baby. 2 of them were standard. One of them was because they thought something was wrong, and they were right. But the first, or ultrasound is an imaging technology. It uses sound waves to create images. So it's not a photograph. It's using sound waves. They bounce off of things. It's hooked up to a computer, and it generates an image of what stuff looks like. During pregnancy, a transducer or a wand is placed either in the vagina or on top of the belly. The on top of the belly is more common, but the other type is an internal ultrasound, and sometimes it gives them a better picture. It emits sound waves. They bounce off baby's tissues, fluids, bones. Then the transducer picks up the echoes and translates them into the image of the baby. So early in pregnancy, so I had an ultrasound at about, I want to say 12 weeks, somewhere in that neighborhood, to confirm the fetal heartbeat and location of pregnancy. So they want to make sure that the embryo has implanted itself in the woman's uterus and not, say, somewhere else. That could happen. Things could implant themselves outside of the uterus. It's called an ectopic pregnancy, and they're quite dangerous. There's an episode of Grey's Anatomy where the woman doesn't die. She has an ectopic pregnancy, and her baby develops fully outside of her uterus, like in between all of her intestines. So it can function because, remember, the baby is providing all of its own support structures. But if it's in the fallopian tube, let's say, it's pretty dangerous because there's not enough space there, and it usually means that there'll be permanent damage to the fallopian tube. One of my cousins had one of those, and essentially her left fallopian tube is gone now. She had an ectopic pregnancy. That ovary, even though it might still be producing eggs, has no connection to the rest of her reproductive system. Later ultrasounds will screen for fetal growth, so they check how big the baby is, and that can help them determine how many weeks pregnant you are if you aren't sure. The location of the placenta, and just general health and anatomy of the baby. Towards the end of pregnancy, ultrasounds can also be useful for checking the length of the cervix, which is the opening to the uterus, as well as to verify that the baby is in a heads down position, because that is the ideal position for labor. Now, I do want to show you